On this episode of Inside Engineering, we take the show on the road to sunny Miami, where we talk with Senior Manager Rob Daoust and hydrogeologist Mike Waldron about, you guessed it, hydrogeology, including a discussion on aquifer recharging. I didn't even know what that was, but thanks to Rob and Mike, you'll be experts on it. Also, if you haven't subscribed yet to the show, do it now if you like this content. We're on Apple, Spotify, Google, YouTube, Stitcher, and more. Inside Engineering starts right now. Inside Engineering, untold stories and fascinating people from the world of civil engineering. This is episode 20, recorded in February 2020. Hydrogeology with Rob Daoust and Mike Waldron. Inside Engineering is an RK&K podcast. Learn more at rkk.com/podcast. And welcome back to another episode of Inside Engineering. We are not in Baltimore. We are here in sunny Miami. It's warm here. It's much warmer than it is in Baltimore. And I'm excited to be here with two guys from our Fort Lauderdale office, Rob Daoust and Mike Waldron. Guys, thank you both for taking the time to come up and be with us.
Thank you.
Thank you.
I appreciate it. You two are hydrogeologists, or you are in our hydrogeology discipline. Rob, you're a senior manager of municipal engineering in our water wastewater discipline.
Correct.
And Mike, you're the hydrogeologist.
I was going to say, he's the hydrogeologist. I'm not.
All right,
That's
so we're going to get into what hydrogeology is, because if you asked me to explain what it was, this would be a very, very short show. But luckily, we have you two guys here to help us out. So, Rob, why don't you start off and tell us what it is that you do here at the firm, and you can throw it to Mike when you're ready.
So I joined RK&K to help build and establish our wastewater practice here in Florida. And so in doing so, I had to obviously start building a staff. And one of the first hires I made was an offer to Mike. He's a hydrogeologist. It's a new service. It's a good niche service. And so I brought him on board as part of the team, and he's been with us for almost 2 years, or a year and a half.
A year and a half, yeah.
So
Exciting. Okay, so Mike, what is hydrogeology, and what do you do?
Well, in the broadest sense, hydrogeology is the study of the movement of water through the earth. Okay, in the broadest sense. But it's a huge field, actually. It's considered a niche service for an engineering firm, but it's a huge field. It goes everything from water quality to water quantity, and how to get water out of wells and how to get water into wells, and I'll get into that. But I'm brought on as a manager in the of hydrogeology in the Florida water wastewater practice, and basically what I do is I collaborate with engineers when they need to build a well or a well system, and also when they need to rehabilitate a well or well system, and that can include anything from a shallow water supply well to a deep brackish water supply well to an injection well. We'll get into that if you want to, and also things like well field assessments and well rehabilitations, where a well isn't performing up to what it should, and you go in and you basically repair it or enhance the performance of the well by increasing its yield.
So one of the things that I think is probably unusual for a lot of viewers is that here in South Florida, our water comes from an aquifer, so it's below ground resource. In most of the country, surface water is used for potable water. So that's the reason why hydrogeology here in South Florida is so important to our water supply clients and for wastewater clients, because they take our wastewater and they inject it into the ground for disposal. So that's why bringing Mike on board made a lot of sense, because it was a niche service that's important to clients here in Florida, and like I said, open doors to helping build the practice.
And so even though it's a little bit different here in South Florida, I assume there are hydrogeology needs elsewhere. So we'll talk about, we'll get into that in a little bit, maybe, some of the other specialty places. But Mike, bear with me here as I ask some questions that may make me look less intelligent. But let's say there's how would a client know that a well is going bad? You mentioned that you rehabilitation or stuff. What's the first sign that maybe something's wrong?
Yeah, well, the first sign that something is going wrong is only apparent to them if they actually have a record of how the well's performed in the past. So sometimes it'll get to the point where even if we don't have records, they don't have records, they'll just know because all of a sudden their yield to their well goes down. Now, it actually can be something like a pump that's gone bad, okay? So they don't necessarily know that. So you have to go in and help them understand that, is it a pump issue? Is it the parts of the pump go bad and the well just won't pump as much? Or is there additional water level decline in the well, and is that what's causing it, and what's causing that? So you have to kind of go through a 20-question sort of thing with them in order to make them understand, okay, here's where we got to start looking. And then at that point, then you can decide whether the well needs some sort of a pump replacement, or if does the well need a treatment with an acid, for instance, to increase the capacity by opening up the pores spaces in the aquifer. So those are the sorts of things that you do to start off with. If they have water quality and they have water quality issues that are starting to happen, sometimes that's a good sign also that the well is going bad, because if a well goes bad in the sense that it pumps from deeper in the aquifer because the connection to the upper part of the aquifer seals off over time, then it starts to pump water with a higher total dissolved solids, and you can sometimes track performance that way. So it's a combination of those two things that you look at when you're assessing whether or not a well is going bad.
So let's maybe walk through a typical project, maybe a water supply well or something. Was that
Sure.
And can you talk us through what that project might look like, the whole life cycle of it? I know there's some stuff at the beginning that Rob, that you're involved with. So maybe the two of you tag team this and give us an insight as to what maybe it takes to do a project like this.
Sure. So there's, like I said, many clients here in South Florida have extensive well fields. So often, for example, there's one client that's looking at doing a well field expansion. So as with any engineering project, the first thing you want to do is get ahead and understand their needs. So there's a lot of positioning work that we spend meeting with clients and going to talk to them about their hydrogeology needs. And if it's a water supply, like a well field expansion type job, they'll generally explain to them, to us, what they need. We'll try to figure out what their critical issues are. Like, is it, are they relocating it because of saltwater intrusion? Or are there other issues that they're trying to address? So that we can then try to figure out, how best to direct them. And then the proposal comes out and we need to provide a technical response. And Mike is obviously the one that delivers the technical response and works from that.
Right. And the project actually kind of maps with a standard engineering project in a lot of ways. I mean, you go in and you initially have meetings, you talk about grant assistance. If they need grant assistance, you can offer that. But typically we go and give them a proposal for the permitting stage and the well design stage. So that if they have wells that they need, that they're expanding their well field, that we take the data that they have in their well field and we use it to optimize a well field design and a well design for the expansion of. Sometimes that involves doing exactly what they did before, and sometimes it involves changing things. It all depends on what the issue is that they're having. So we work and collaborate with our engineers, and we basically design wells and give our engineers the pump constraints or the pumping conditions that we think they're going to see in the well proactively, because we have literature on the aquifers, and that's a way to basically determine what kind of well performance you're going to get, what kind of yield you're going to get, and how much drawdown. And from that, knowing where the water has to go and how much pressure they need on that side, you can give them total design head estimates. And that's very helpful to the engineers. That's one of the main purposes of having a hydrogeologist who understands that, is helping the engineer decide sort of what size wells do you need, what size piping do you need, and even what horsepower you might need for your pump. So that's one of the major considerations. And then from there, you go to the bid stage. We actually produce technical specifications for the well that go into the overall program, and hopefully we've captured something like piping and other aspects of the expansion as well, which is part of the point of having me around, is to help capture the rest of that job, right? So, and then from there you go to your pre-construction and your health and safety planning, and from there you go to, you know, how are you going to discharge your water? You know, is the water brackish or is it fresh? Makes a difference in terms of the discharge requirements. So you have to start the permitting process for that before you get on site. And then there's all the on-site work, and that involves everything from collaborating and basically not supervising the driller, but observing the driller, because it's typically he's contracted with the owner, and recording everything that they do as they complete the well. And the real meat and potatoes, though, is the testing of the well after it's constructed. And that's where our services are more critical. We do on-site construction inspection, but at the testing phase, that's where we can actually take data that will analyze how efficient the well is and how well it's going to perform relative to the technical specifications and the design rate that we need. So it maps sort of with an engineering project in a lot of ways. And from there, you know, you go to your, when you're all done, you have a report that gives them a complete picture of all the data that was collected, as well as the analysis of the well, and they can use that in the future for what we were talking about originally, which is they have a baseline from which to work. If that well doesn't perform like it did when it was first constructed, they can just go to that report, open it up, and say, oh, we've lost 20% of our capacity. It's time to do some rehab work.
And this is why I like working with Mike, because he's humble, and I think he downplays the role that hydrogeologist and he plays in a lot of projects. The permitting stuff that you talked about, he gave a very simplified overview. You know, it's complex down here in South Florida. To get permitted for a water supply, if it was a well field job, you have to look at water supply permitting. That's a state agency that handles that. It can be a very complex and involved process. Hydrogeologists are important for that. The permitting of the well itself, that would be the Florida Department of Environmental Protection. There's several steps, several different types of permits that they have to engage in, and it's a complex process, and again, he's critical to that. And then aside from just, you know, the performance of the pump and the pressures, he's the one that's giving guidance to the engineers that are looking at what kind of treatment process to use for the water that they're pumping out of that well, because if it's a superficial water, superficial aquifer water that they're pumping out, is probably pretty fresh. It can probably go through a different process than if it's brackish water from deeper down, and those need to go through reverse osmosis or some type of membrane to reduce the salt concentration so they can be used for drinking water. So, you know, he's playing a big role in directing not only, you know, how much water are they going to get out of each well, but also the type of process that they can use on the plant side to treat the water before it goes out.
I mean, you've talked about you just talked about a whole bunch of stuff, which, you know, just as you're talking about it, I'm just thinking, like, this is a huge service to the client. Like, all those different things, that expertise is so valuable. We often hear about permitting and how big of a challenge it is to get those permits, and sort of the value we bring to helping navigate that process for the client. I mean, for you on a project, you know, and either one of you jump in here, like, what is the part that is A, the most challenging, and maybe B, the most personally interesting for you, or the part you get most excited about?
Well, you want me to start?
Yeah. I'm going to take the diplomatic way out.
That's good. That was well played.
The most challenging aspect for me actually is the communicating with the client and communicating with the engineer typically, to get to the point where I understand what his expectations are. That's really the difficult part, because as a lot of folks, because they're not familiar with hydrogeology, just want to know the answer to 5 questions or so. You know, they don't want to know too much because it's confusing, right?
Yeah,
it can be overwhelming because that's not their field, and it's really just terminology. It's not. Rob, I know he's thinking I'm humble, but really it's just a different way of talking about the same thing that engineers talk about. An aquifer is just a pipe that has millions of little pipes in it. Okay, then there's like a higher or a lower conductance, okay, than a pipe, and that's what an aquifer is. It's a pipe that has more resistance in it, kind of like a circuit. right? And we measure that as a term that's called transmissivity. If I go into all this with some engineers, they don't want to necessarily know all that much. They want to know how much will it cost, how long will it take, and
how much better will it be?
How much better will things get for me, right? So, so I have to, kind of gauge how much information I give them based on what their desires are, what they really need, and that's the biggest challenge for me.
Strong communication skills,
right,
are big. We hear about that a lot too.
I'll play off that. I think that's important, and it plays out in multiple arenas. Like if you're doing, as you're developing plans and specs, or you're trying to communicate, a scope, and you're negotiating a scope. You want to communicate enough to let the client know what they're going to get. You don't want to over communicate so that you're scaring them, but there's a fine line between making sure that what you're covering is actually detailed in specifics in the scope, so you're excluding things that are not within the scope, because there can be some vague. If it's not taken and it's translated incorrectly, it can mean that there's opportunities for scope creep or some disagreement over what we're supposed to be providing. So that communication is really important in all aspects of it, not just in delivery, but also in contracting and scope development.
Absolutely. Okay, the most rewarding part, or the part you get most excited about personally?
Basically fixing the problem. That really is where we get our real enjoyment is, and knowing that we can fix the problem is kind of nice too, but when it's all done and you have fixed the problem, it's more rewarding. Knowing is great, but it doesn't get you the job. So,
it's not even half the battle.
What he's talking What he's talking about is the real battle. Is that fine line between making them understand that they need you and not scaring them off at the same time. Because there are things that are technical, and they're would be worth them knowing, not necessarily a bad thing to know it, but it could be a little scary.
Right.
Now the good news is this isn't brain surgery, and I can tell you that nobody's
a brain surgeon might disagree with that.
If you get 20 gallons per minute less than you thought you were going to get, nobody's going to be hurt. Okay, so that's the good news. And in that same sense, not being an engineering discipline, I'm not putting my stamp on a bridge. So to that extent, it's not really that scary of a field, and I feel that it can be technical, but it's a service that people need, and I really enjoy it, and I've enjoyed it since I was like in 8th grade, this kind of thing. So,
what would you say to any 8th graders out there now?
Well, if you're helping other kids answer questions, you're probably going to want to go into the earth sciences. That's what I'd say.
Right.
So for me, again, another reason I like working with Mike, what I find rewarding is when a client approaches us and they have an issue or a problem, and Mike is able to think through and not just deliver, here's the straight and narrow path that you originally thought, but sometimes he comes up with an alternative pathway, and it might not involve the exact same linear pathway that the client wants, but it's to their benefit. And he's very good at communicating that with the client. And sometimes that involves bringing in engineers and working with them too to come up with a complete idea. And I enjoy when the client responds positively and sees that we're bringing them more benefit than just, here's the cookie cutter that you brought us, here's the cookie cutter response that you would have got. But rather, we're sitting here and we're thinking for you, and we're thinking ahead, and we want to solve your problem in the best way that we can for you, not just, following a script of, here's what you wanted, here's what we're going to do. And he's really good at that.
Can either Mike or the two of you think about, without going into a lot of specifics, but think about a particular project that you've worked on that had some challenges. Maybe they were typical challenges, or maybe they were atypical for that project. But can you talk us through a project like that had some challenges, and what they were, how you identified them, and how you came up with a solution and implemented it? It'd be kind of fun to walk through.
Would you like to do the water supply at?
Yeah,
with a water supply well.
Yeah. Let's do that.
Well, we recently helped a client expand a well. They expanded a well field in terms of water quantity, but they replaced 13 water supply wells with 4.
Oh wow! So
it
going down, but
higher rate wells,
higher
Right,
rate,
yes.
okay,
right? Which involved obviously the wells had to be a little bit bigger, but they were in the same production zone. So the key issue there was instead of being screen and gravel, which is when you put a screen in and you put gravel on the outside, which reduces
pretty good name. Okay,
right,
gravel,
right? And that filters the formation from coming into the well. So, but it also increases that resistance, and it increases drawdown in the well, and reduces the yield from each well. So that's
and bear with me here. Drawdown is
the decline in water level when you pump the well.
Yeah,
Okay.
so when you have a well, think about it, it's just like a straw, so you stick it down to the ground. The water, it's like you've got the water right around the straw is a little lower than where it's elsewhere because you're sucking it down
Right.
right where you're pulling it up.
Right.
Okay.
So it's sort of like a function of the efficiency of the well. So what we did is replaced it with open hole wells, which have no screen and no gravel pack. However, there's a lot of sand sometimes when that happens, and you have to develop out the sand. So what we did for them is we proposed these 4 wells, and we had them constructed, and we did a lot of extra development on the wells to make sure that all the sand was out, because they were going from what's called a lime softening treatment, which doesn't require much filtration for particles, and to a nanofiltration, which is a membrane system that does require filtration. So quite a bit of development needed to be done to get those wells able to be pumped without having sand come out of the well. So that was something that was a little bit innovative that we did, and it turns out that we were able to get like 3 times as much water from each well and meet their capacity requirements.
wow.
So
I'm just thinking about like the technology behind that, and it sounds like there's some cool stuff going on there to make that all happen. Anytime you say the word nano, that's cool.
Yeah, so I think it was advances in water treatment because lime filtration is one of the older ways that you can treat water, and nanofiltration is relatively newer. So newer technology allowed for a different type of well to be used.
And it's a major driver down here for business because you've probably heard of disinfection byproducts from when you put chlorine in water to disinfect the water. Then you get the trihalomethanes and haloacetic acids, which these are carcinogens. And the EPA has determined that they need to be below 60 parts per billion, something like this. And a lot of these places can't meet that criteria using lime softening. So they're going to the membrane systems for that reason, because they need to meet those requirements. And as a result of using nanofiltration, the water comes out without these compounds in it.
Cool. So it's a 2-for-1 in some way.
It's a 2-for-1. And well, I mean, and they wouldn't go to the nanofiltration unless they had this issue.
Right.
And it's really due to the color and the organics in the water in the first place. That's something we really can't do much about, because if they want to use this particular shallow aquifer down here in South Florida, they're going to have that issue.
Okay, so before we're sort of in a more of a micro view of things from a technology or technical standpoint. Is there anything else before we sort of take a step back to a wider view of the discipline and stuff? Anything else you want to talk about?
I think there's a few other areas that he practices in that are really interesting. Injection wells, I think, are important. Here in South Florida, they're decommissioning ocean outfalls. So they used to take wastewater and shunt it out into the ocean. Those are being decommissioned. So there's heavy interest in what do you do with that excess wastewater that you can no longer dispose of into the ocean. A lot of that is being treated and used as reclaimed water for irrigation purposes, but a lot of it is going into what are called deep injection wells. And so Mike has done a lot of work in deep injection wells. And then he's also got a lot of experience with aquifer recharge and recovery, or aquifer storage and recovery, which is, I'll let you, since I couldn't say it right the first time.
The injection wells, it's somewhat unique to Florida, but they're starting to do what are called recharge wells even up in Virginia. That's one of the major things, that they're treating the water to drinking water standards up there, and they're going to inject it to basically improve subsidence that's occurring in the aquifer. The Potomac aquifers are actually causing the withdrawals from the Potomac aquifers up there are causing land subsidence.
So they're trying to supplement.
Yeah, so like
supplement the water
in the ground,
right?
Okay.
Yeah, so when you combine like in Norfolk, the area in the Hampton Roads, the land subsiding, you have sea level rise, you've got two problems. One's making the other worse. So the idea is recharge the aquifer to help stop the subsidence as part of the resilience approach for the area.
Yeah, so part of the
Wow,
idea behind hiring John Mayhut and myself, and John I've worked with for like 15 years, is another hydrogeologist here at RKK, and is using our background in deep well injection that we've gained here in Florida over the last 25, 30 years to supplement our knowledge for those types of recharge projects up in Virginia and North Carolina and South Carolina. And aquifer storage and recovery is slightly different. It's not just recharging the water into the ground, but recharging it or injecting it in the ground for use later, or seasonally, or in a drought condition.
Yeah, so here in South Florida, there's a lot of water. We're surrounded by water, right? But we actually have a very distinct wet and dry season. And water demands tend to be higher in the winter, which is our dry season. And so as an alternative use, rather than continuing to draw from the aquifer, the idea is during the wet season when we've got a lot of rain, which is the summer, and lower demands, you take some water and you inject it temporarily down into the aquifer, and then you pump it back out for use during the peak periods during the winter. So it's
Using the aquifer as
a little storage tank. Exactly. And then there's other applications for that idea. The South Florida Water Management District, which is in charge of Everglades restoration from the state perspective. They've gone through various iterations of looking at ASR as a temporary storage area or feature that they could use for distributing water into the Everglades on a more natural cycle.
If I'm not saying anything right now, it's because like my mind is just, I'm trying to wrap my mind around all this. It's wild. I never, like a natural storage tank, you're essentially putting the water in and taking it out later. And that works?
Well, you're
doing it.
That's a good question, actually. Does it always work? It hasn't always worked in Florida for a couple different reasons. Typically, when you want to do this for seasonal use or for something like drought resistance or resilience, you're doing it into a brackish aquifer. You're putting fresh water into a brackish aquifer. Okay, now that aquifer wouldn't normally be used in that particular area. So you're environmentally, when you pull it back out, you're not impacting wetlands in that area by pulling it from the upper aquifer, which is one of the major drivers.
The brackish water still down below, but you're getting that.
So you're not drawing down the wetlands if you pull it from that lower aquifer that's brackish and it's confined from the upper aquifer. So that's what they're doing in Florida. They haven't had 100% success with it because sometimes it's difficult to get that mixing zone correct between the brackish and the fresh water. And there's other issues chemically that happen when you inject water. You want to inject water that doesn't have a lot of dissolved oxygen because that can leach metals from that aquifer. So there's a lot of things that have gone wrong in the past. Now, Florida is probably ahead of most states in terms of solving those issues. And having worked down here for 30 years and at least one other company that specialized in it, I have a pretty good handle on what those solutions are and how to avoid issues when you do those sorts of ASR well fields.
And he, again, is being humble because there's definitely one client that he's worked with where the ASR system that they have is quite impressive and has been functioning for several years. It beats all of their peak season demands during the winter. It's a smaller community that has a substantial swing between low and peak season demands. And it allows them to basically, I think, use almost all of their summertime resources in the winter when they need them the most.
Wow. And I'm trying to think of what there's so many things I want to know right now. It's how much water are we talking about when we're injecting here? Like I don't know anything about this. So
typical wells are between 500,000 gallons a day and 1 million gallons a day.
Okay.
But for instance, and John Mayhut and I have worked on that site for over 12 years that he's talking about. They are injecting stormwater that comes into these lakes through a canal in the summertime, and they're using it for two purposes. One, for a standard surface water treatment plant, and they're injecting it into ASR wells so that they can recover it during the dry season that he said. But they've got probably over 1.5 billion gallons in the ground available for use. So they're pretty drought resilient.
Yeah, and what would the typical demand be during the dry season?
Probably 300, 500 million the most.
Oh wow! So they're
Yeah, they've got a few years of water.
Yeah.
okay. So that's sort of how it works. Is you're not just
You want
putting
to
in
put,
what you want to
put more in there.
You put in
get
more
back.
than you need so that you push that mixing zone far enough away from the well field so that you don't pull it in when you need it.
Yeah, so you're only working. So it's like you got a little icing around the edges, and you're only working with the middle.
Okay, so that aquifer can keep expanding out, or is it limited?
It's limited because at some point on the outside edges, let's get that drawdown thing again.
yeah.
You actually go out further than the well can draw down the aquifer at all.
Okay.
And once you hit that zero drawdown point, you're wasting water.
Got it. It's water that you can't access.
You can't get
Right.
back.
You couldn't move like the access points further out.
You could move wells further out, but that's expensive.
Yeah,
so
drilling
okay.
a new well is not cheap.
Got it. Okay. Okay. I feel super educated right now. This is good. All right. What else? This is interesting. I love it. All right. What else haven't we hit on from a technical standpoint? I want to get all the cool things that you do.
I think we talked about a little bit about well rehab.
Yeah. Well, rehab is important here.
So instead of drilling a new well,
Yeah, 'cause-
we're rehabbing an
Save money.
existing one. Okay.
South Florida really grew in size in the 50s, 60s, and 70s, and so you've got a lot of aging infrastructure. A lot of the wells that were installed in well fields were built during that era, and so there's a lot of clients where they've got wells that are older that need to be rehabbed, and Mike's done a lot of that kind of work.
Right.
So what does that entail? Rehabbing.
Typically, it's some form of chemical treatment, but it can be. I mean, you can do it several different ways. You can do percussion treatment, which is sort of like hydrofracking, but different. Not actual fracking.
Not actual. Okay.
But pressure fracking. You can do acid injection, which is more typical because most of the wells here are calcium carbonate based. You know, the formation is calcium carbonate. So a light acid treatment will actually open up the portions of the well where the water comes in that typically calcify.
Okay, so there's some kind of buildup that's happening.
Buildup. It's kind of like arterial sclerosis, okay?
Yeah, okay.
Like we have. But what happens is as water gets close to a well and gets close to the borehole, the pressure of the water goes down. It's called a partial pressure drop. And that causes a supersaturated solution, like a water that's been sitting in a calcium carbonate aquifer forever, to precipitate calcium, and that builds up on the fractures where the water is coming into the well, and eventually seals them off.
Okay.
So you have to add acid, and it's a low strength acid method, which is a lot safer than high strength acid to work with, and you just pump the water in over a long period of time, and you dissolve those deposits. And by doing that with a low strength acid, when you pull the water back, it's at a 6.5 pH. You don't have to neutralize it. You don't have to take it someplace to dispose of it. So it's a really unique sort of treatment method that works very well in this particular aquifer. Now, if you're in a sandstone or something like that, you have to use a different type of acid. But here in Florida, it's fairly simple to use something like a muriatic acid, hydrochloric. So.
Thank you. Yeah, I didn't know what that was. So thank you. That's good. I need all the help I can get.
and sometimes that doesn't always work, but when it doesn't work, it usually opens the door to investigating and finding out that there's other issues with the well that that you weren't aware of. So it's I think that's another key aspect. And then the follow-on stuff, I guess, is there's regulatory work that's always the well. He mentioned permitting. He mentioned testing, but in order to keep your permits here in South Florida, you have to do a sequence of tests every 5 years. And we also provide that service, and he does a lot of that as well.
Testing on the wells themselves so that they can stay certified. Okay.
Yeah, and if they typically it's they have 5-year renewals on the. They don't actually have to renew the permit, but they have to have it audited every 5 years. So that's another thing that typically you're getting 20-year permits now. So most permits require 5-year audits, and that's something that we help
the client out with it as well. Yeah, the audit.
But there's also facility work plans and things like that are another agency requires water supply facility work plans. That's part of that South Florida Water Management District's lower East Coast regional water supply requirements. They require every municipality to do these water supply plans every 5 years. So that's another small permitting thing that we get involved in.
Well, and that ties into planning. So, again, it's hydrogeology, you have your fingers in everything, right? So if you're doing a water supply plan for a client in South Florida, there is a limit to the amount of water that clients are allowed to take from the superficial aquifer. They have requirements to meet alternative water supplies, and hydrogeology is often one of the ways, like aquifer storage and recovery is an alternative water supply. The use of the Floridan aquifer, which is the lower one, is an alternative water supply. So when you're doing water supply planning or of any type, typically you want to engage a hydrogeologist that they can provide you ideas and conceptual contributions for alternative water supply plans.
There's so much going on here. So we talked a lot about South Florida. There's obviously needs outside of this area, but a little bit different. Do you want to talk about some of the other areas that we're in and sort of the expansion of this group?
So when I came on board, I hired not just Mike, but also John Mayhat. John was based in Fort Myers and was working with clients mostly in Southwest Florida, but they're sort of a team. They've worked together, I don't know how many years you said.
Like 12, 15 years.
So it made sense to bring them both on board because they've worked so closely for so long. And it worked out very well for RK&K because we have a client up in the Hampton Roads area that is a good client, and as Mike mentioned, is starting a big project for aquifer recharge to combat subsidence. And so John was willing and interested in relocating, so we moved him up to he's now in the Newport News office, and he's engaged with HRSD on a regular basis, and I think we're positioned for some work there, which is exciting. And through his, by just being up there, he's now networking with other clients in the Mid-Atlantic about well work. So, there's opportunities for that where we already have existing clients and existing relationships. It's a need that we can now meet that they didn't know we could meet before. And then there's other areas where we're trying to grow, like Texas, where there is very similar to Florida, a lot of water supply is taken from below ground. And so there's opportunities to use this, I think, as a door opener in other market areas.
Yeah, that's true. And I'm working with John on several of his jobs now, just helping him out on small tasks that he's got in Maryland and North Carolina and in Virginia. He's got, he's already done probably 2 or 3 projects, and he's got 5 or 6 projects that he's tracking now on proposals. So he's very busy. He's busy up there,
up and down the coast. Yeah.
So
that's exciting.
Trying to help him a little bit and trying to, to talk to folks about opening up Texas, because it is an area where aquifer storage and recovery is going to play a big part in their water supply programs there. It's just it's a natural fit for the issues that they have in Texas.
Sure. All right. Well, that was so much, because I'm just I'm still thinking about it all in my head. Well, let's talk a little bit. We've talked a lot of technical here. Let's talk a little bit career, and how did you guys each get to where you are in your career? Can you just sort of go back in time and talk about how you got here?
I'll go first. I would say, I would never have predicted that I'm where I am today. I went to college, and my major was geography. Engineering was the last thing I ever thought about. Went to graduate school. I'm a wetland ecologist by training, so I spent time in the Everglades doing research on nutrients on Everglades plant communities. Did PhD research on nutrients in wetland communities in Massachusetts. It's like ecology was not on my radar, or engineering was not on my radar. But I ended up taking a job in consulting after graduate school, and I liked it. And at that time, it was mostly just doing environmental work. Then I moved to another firm. They were primarily a water wastewater firm, so I was a little bit of an oddball. But there's something about engineering that fits well for me. It's like I can listen to clients and I can understand needs. And I think my boss, who was my boss for 6 out of the 10 years I was there, He was a good mentor, and he kind of taught me a lot about business development and managing clients. And he could see that, I like to listen to clients. I like to bring clients solutions. I might not know the answers, but that's what I actually find interesting because I like to learn all the time. And so I like to listen to the clients. I like to hear what bothers them, and then I like to go back and put the puzzles together to see if I can bring them an answer because I'm learning at the same time, and that's what excites me. And so that's kind of why I think I ended up where I am, is because I like to learn all the time. My original thought was I was going to be a PhD, postdoc, and then tenure track, and I think I would have been bored. The constant challenges in consulting, I think, are what keeps me going every day because I'm always learning something new, whether it's being from Mike or one of the other staff in the office. It's rewarding.
Is there something you wish you had known earlier on in your career?
Absolutely. Project management. Nobody teaches you about project management. Nobody teaches you about profit. Nobody teaches you about days revenue outstanding. How many days has it been since you sent an invoice out? The business aspect of it that's actually what drew me to why I liked the consulting job, is because I was learning all this new business stuff. But project management, my first firm was heavy on the Project Management Institute approach to project management, and if I had spent some time in college and actually understood what that was, that would have been very useful, I think, because that's a key component to what we do, right? It's we make money based on projects, and so if you're managing your projects well, then the company is going to do well, and I think it's something that everybody could have benefited from.
Indeed, that's good. That's good. Mike, take us back in time.
Well, I came down here from upstate New York in '89, and I'd been up there working for my grandfather at a golf course, looking for a job in my field for several years and couldn't find anything. So I got down here and was almost immediately hired by a company, a pretty big groundwater consulting firm, on a 6-month contract to inspect injection wells, the same type that we still do. That led to a 17-year career at that company.
Unexpected turn of events.
Unexpected turn of events, right? And I learned quite a bit about groundwater and groundwater consulting from those guys. And eventually I moved to a smaller firm to learn about aquifer storage and recovery, because it's the one thing that we didn't do. And it was a good opportunity, and I met John Mayhut, and we collaborated a lot, and did a lot of more interesting things, even than I did previously at the first firm. And so after learning, quite a bit, I never really expected to stay necessarily in the field doing this, but I did move, away from doing the environmental work and more into the water supply, because I saw that the environmental work was more of a commodity and wasn't as interesting as water supply and alternative water supply and brackish aquifers and things that are really more interesting technically, but also, becoming a real market driver and becoming an important part of, keeping your career going. So that's why I kind of gravitated towards what I'm doing now.
And what would you tell yourself all those years back, if you could give yourself some advice or something you wish you'd known?
I would have probably learned sooner how to write proposals, how to understand contracts, because I spent a good 8 or 9 years almost in the field. But it does have its advantages, because now I know what the driller's actually doing out there,
right,
versus just kind of guessing.
Yeah.
So that's an advantage that I kind of pride myself on because I did at the time. It was a company that had a lot of project managers, and to become a project manager, you really had to prove yourself, and that's a good thing. I think there wasn't anything wrong with that. I also would have probably stressed field communications and project management to field communications more, and I do that now. When I have someone that I'm mentoring, I'll explain that you have to communicate not only clearly, but you have to communicate the details, because it's really where the issues are, in the details. And understanding contractual agreements is an important part of that, because if you understand, this is the owner, this is the contractor, there's certain things you say to him that you don't say to this person.
Right,
so
right.
Understanding those contractual relationships is really important when you're in the field, because if you don't understand them, you don't really understand how to couch your communication.
Right.
So,
which is a big part of helping the client
Right.
in the best way possible is
Right.
how you communicate, what you communicate, so that
So
everything's,
things go smoothly.
everybody's happy.
Things go smoothly.
Yeah, and
Right.
understanding the contractual relationships about who you're reporting to and who you're giving instructions to, so it's not possible that you don't unintentionally convey something to a party that you don't have authority to convey something, and they interpret that, and then that upsets the client.
Right.
So,
Right.
those are critical things.
And I learned those things pretty well at the company that I was at originally, but I also learned when I went to the second company that not everyone is aware of those kinds of things, and they need to be mentored a little
Sure.
bit. So those are things that I think everyone should be mentored on.
That's good stuff. Those are good tips. All right, so we've talked about a lot. Is there anything we haven't, before we get to our picks of the week, is there anything we haven't talked about that you guys want to mention or get into?
I would just say, I think this is a great new service here at RK&K. I think this is a great firm where just the way that we operate has allowed John and Mike to really get integrated throughout the firm and work with clients no matter where we are. I think there's a lot of excitement about the opportunity to grow here in Florida, grow elsewhere, and bring this service to clients and bring RK&K's great level of service to clients here in Florida. I think we provide a kind of service to clients that most consultants down here in South Florida don't, and I think clients are going to start recognizing that and appreciating that. It's important.
Yeah, and I think it's great that you do this because nobody does this sort of thing internally. I mean, I haven't seen it in the 30 years I've been working in the field.
We love doing this. This is fun. I mean, I especially enjoy it just because I feel like I get to learn
Right.
every time. But yeah, it's been really cool that the company has been behind doing this podcast and getting the word out about all the cool stuff that we're doing. Hydrogeology today. That's really good. All right, let's come to that time in the episode, gentlemen, where you're going to give us your picks of the week.
If you go to Disney World,
Which,
and
if you're in South Florida,
you're in South Florida, you're going to
do.
do, and you go to Hollywood Studios, get the Black Marlin Porter at the Baseline because it's awesome.
Okay.
It's a great beer.
The Black Marlin Porter at the Baseline.
Yeah.
All right. See, that's a good pick. That's that's a legitimate. You can put that down as a check mark to do.
Yeah.
My pick of the week would be if you're stuck in snow in the Mid-Atlantic or Baltimore, and you're looking for career opportunities, come on down.
That's right. Less snow.
Less
That's
snow.
good.
It's beautiful. It's 72 degrees outside. You can't beat the weather here.
It is February.
It
I was
is
gonna say,
February.
February. It's 72 degrees outside, and it's not. It's about 30 degrees less than that right now in Baltimore. So I'm staring out the window here, sort of wishful thinking. I see palm trees. And
Yeah, I'm Canadian.
makes me happy.
I'm going to Canada on Thursday. Trust me, I'm not looking forward to it.
Oh, yeah, no, that's... how cold is it there right now?
I don't do that. I do it in Celsius, so I can't tell you in Fahrenheit, but it's like minus 10 today.
Okay. So that just... Well, no, it doesn't matter if that's Fahrenheit or Celsius. It's
cold.
It's cold. All right, guys. Well, hey, I really do appreciate the two of you coming up here to take the time to talk about hydrogeology and the discipline and the cool stuff that you guys are doing. Thank
pleasure.
you, Rob. Thank you, Mike.
Thanks.
Appreciate
it.
And thank you all for joining us for another really good episode of Inside Engineering. We come out every other Tuesday, and you can check us out at our home at rkk.com/podcast, where you can watch or listen on demand. You can also find us on a whole bunch of different podcasting platforms, including Apple, Spotify, Google, TuneIn, Stitcher. I try to say them all every time, and then I realize I should probably just not say them all because it's a lot. Also, if you haven't already, please subscribe and leave us a review. You can do all of that on any of those platforms. It really helps us get the word out about how cool this show is and the great guests that we have. So again, thank you guys for coming. Thank you all for watching, and we'll see you next time on another episode of Inside Engineering.